Let's try to do some examples where we use that formula for the derivative of f inverse to calculate f inverse prime for some examples. So I'll do f of x is equal to x cubed, and let's ask the question, what is f inverse prime evaluated at, say, let's evaluate it at 8. So let's just recall up above what was our formula for f inverse prime. We learned that f inverse prime of x was equal to 1 over f prime of f inverse of x. If we apply that to our example, what are we going to get? We need to compute f inverse prime of 8, which is f inverse prime, or rather 1 over f prime of f inverse of 8. So we need to calculate two things. We need to know what is f inverse of 8, and then we need to apply f prime to that. So let's calculate f prime. In general, f prime of x, if f of x is x cubed, f prime is going to be 3x squared. What about f inverse? We need to know what is f inverse of x. To do that, we can write down what it is immediately. Our function is x cubed. We saw many times before, f inverse of x is going to be x to the 1/3 in this example. So therefore, f inverse of 8 is equal to 8 to the 1/3, so the cube root of 8, which is just 2, right? Because 2 cubed is equal to 8. So this quantity that we're calculating is 1 over f prime of 2. And we know what f prime is, so this is 1 over 3 times 2 squared. So 1 over 3 times 4, so 1 over 12. So there's our answer for what is f inverse prime evaluated at 8. Here you might be thinking, well, couldn't I have done this a different way? Couldn't I have just calculated f inverse of x and then differentiated it to get f inverse prime? Yeah, you certainly could. So there's actually two different ways to solve this problem. And we should get the same answer. How would it work if we did it the other way? So we just calculated f inverse of x is x to the 1/3. So let's just check that our answer is correct in a different way. So we just calculated f inverse of x was x to the 1/3. So f inverse prime of x. What happens when we differentiate x to the 1/3? Remember how it works? You bring down the 1/3 and you subtract 1 from the exponent, so it becomes minus 2/3. So therefore, f inverse prime of, what's our x value? We're trying to evaluate it at 8. So this is 1/3 of 8 to the negative 2/3, which, how can we evaluate that? That's 1/3 of 8 to the 1/3 raised to the minus 2, which is the same as 1/3 of 8 to the 1/3 is 2, and then raised to the minus 2. So you see that's 1/3 of 2 to the negative 2 is 1/4, so 1/3 of 1/4, which is 1 over 12. See, that's exactly the same as what we got up here. So in this case, we're able to calculate f inverse prime of 8 in a different way. You might be thinking, well, why is this even useful? Let's do another example where doing it this other way might be a little harder, and our formula that we learned is actually quite useful. Let's try this on the following function. F of x is equal to x cubed plus x. And let's ask the question, what is f inverse prime of 2? First, before we even start, we should ask, Does this function even have an inverse? We knew it was true for x cubed. Yeah, we already knew this had an inverse. Does this function have an inverse? Remember how we needed to check that? We need to check that the function f is 1 to 1. If you go back in your notes, we did that precisely for this problem, for this function. We looked at x cubed plus x, and we deduced by looking at the derivative of f, we deduced that this function was actually a 1-to-1 function, so it really does have an inverse. So that's just a comment I wanted to make. We actually know that this function does have an inverse. Let's go ahead now and calculate f inverse prime. So evaluate it at 2. By our general formula up here, that's going to be 1 over f prime of f inverse of 2. And we want to simplify this. So we need to know two things. We need to know f prime, we need to know f inverse. What's f prime? F prime is 3x squared plus 1, a differentiated x cubed plus x. So I get 3x squared plus 1. What about f inverse of x? What's this? In this case, let's see what happens when we try to do that. Remember how we compute the inverse of a function? We did a lot of examples. Remember how we did that? We set up an equation, x cubed plus x is equal to some given number y, and we tried to solve for x. This is actually not so easy to do. How do you solve for x here? This is x cubed plus x. There's not an easy way to do this. So here we run into a problem. This is kind of hard to do. Let's try to think about what we can do in this situation. Here I'm trying to compute f inverse of x. But you notice that really all we need in this calculation, all we need is just f inverse of 2. We don't need an explicit formula for f inverse of x valid for any x. We just need the value of f inverse at 2. So maybe if we're lucky, we might be able to guess what is f inverse of 2 even without doing this calculation. So let's try to see if there's an easier way. Here, as I said, we only care about f inverse of 2. So if we want to find what's f inverse of 2, remember we have to answer the question, what value of x, when I plug it into f, will I get 2 out of that? So which x satisfies x cubed plus x is equal to 2? That's the question we want to answer if we want to calculate f inverse of 2. And what is that value of x? Well, in this case, you can actually kind of guess it. Try a few values of x and see what you get. So think about if I plug in x equals 0, I would get 0 cubed plus 0. So that's not going to work. If I plug in x equals 1, I get 1 cubed plus 1. That's 1 plus 1, which is 2, which is fantastic. So here it's actually easy just to guess. The value of x we're looking for is x equals 1, since 1 cubed plus 1 is equal to 2. So we're kind of lucky that we're able to guess it pretty easily. So the conclusion is that f inverse of 2 is equal to this number 1. So we got it without doing this kind of hard calculation up here. So now we can go into our calculation. We have 1 over f prime of f inverse of 2 was 1. So that's 1 over 3 times 1 squared plus 1. I'm plugging in 1 into f prime. So it's 1 over 3 plus 1, so 1 over 4. So we were able to solve this problem using this nice formula we derived for the derivative of f inverse.